Welcome everybody to another jam session where we are taking the ideas that we developed in the Haskell part of the course and show how we can use them in other languages that you may use at work and that are not pure functional languages like Haskell. And this time we're going to take a quick look at Scala. Scala is a hybrid functional object-oriented language. It's not a pure language. It's an imperative language. It has full side effects. It runs on the JVM. And if you're a Haskell programmer, you will feel very familiar with Scala. But also, if you come from C#, you will find that Scala fits like a hand in glove to you. And of course, for Java programmers, Scala also has a lot of benefits in terms of conciseness. Let's look at the Scala cheat sheet to go through some of the features. Scala has two kinds of variable declarations. You can define a var, which means that you have a mutable variable, or you can define a variable as a val, which means that it's read-only. And so in that sense, Scala supports immutable values, but the standard library has a wide variety of data structures, including mutable data types and immutable data types. So it's up to you as a developer to pick and choose which kind of programming fits better. So here are, let me kind of make this a little bit larger. Here's how you define functions in Scala. You write def and then a function name, parameters, and then the right-hand side. And Scala often can infer the return type. In that case, you have to write equals. So in this case, this is a function that takes an int and returns x times x. And the inferred type here, a return type, is int. We have seen type synonyms in Haskell. And in Scala, it's even using the same syntax. So you can define a type alias, type r equals double here. And then wherever you used to use double, you can use r. Here we see an example. And I'll make that even a little bit larger here for you. Here's an example of an anonymous function, of a lambda expression. And you see the lambda expression looks very much like Haskell. In Haskell, remember, it was slash parameter single arrow expression. In Scala, it's argument list with types, double arrow, and then the body of the expression. We have seen several times in the lectures in Haskell that where we're using the range comprehensions, square bracket 1 dot dot 5. Scala also support those, and instead of dot dot dot, it uses 2. So if you write 1 to 5, you get a sequence with the values 1 to 5. And of course, Scala supports all the familiar higher order functions on those collections, such as map and filter and reduce and so on. So here, for example, we see mapping the function times 2 over the list. And remember, in Haskell, we used sectioning. We would write this function as open paren star 2, close paren. And in Scala, instead of using sectioning with parentheses, you can use underscore. So you write underscore times 2, which means the function lambda x times 2. And I must say, often the underscore looks pretty nice because it gives a very visual indication of where the argument is plugged in. And so here you see, for example, that I'm passing the operator plus as a function and then putting the 2 underscores there. But of course, you can also write it like this. And in Scala, there's many ways to write the same thing, so you can also write a kind of sectioning thing. But I prefer this syntax. All right, so where are the data structures? I want to go here. Tuples. In Haskell, we used tuples a lot. And the syntax of tuples in Scala is very similar to Haskell. Round parentheses and the values. And just like in Haskell, the types of the values in a tuple can be different, and the length is part of the type. And that's what we see here. This thing here is tuple 3, and it has 3 type parameters. You can do a simple form of pattern matching with tuples. So I can kind of define a tuple here on the left-hand side, and it will bind, in this case, x to 1, y to 2, and z to 3. Here's the notation for lists. If I want to declare a list, I write list 1, 2, 3. And the idiom in Scala is that you use factory classes like list, and that you don't write new. So you define a class list, and then you define a corresponding object list, and that has an apply method that takes these parameters. And this apply method is something that you don't write in your code, but that the Scala compiler will call when you don't use a name for your method. And Scala has many more tricks like that, with special methods that have special meaning to define getters and setters and indexers and so on. Another thing that I should mention is that Scala also supports extension methods, just like C# and Kotlin. So when you have a class, you can add new methods and properties to that class without having to touch the definition of the class. That's something I like very much, and that also corresponds to the Haskell style, where you define your algebraic data type. There's no methods defined there, and you define all the operations on those types separately. The control structures in Scala are standard conditionals, do, while loops, for in loops. Scala also supports comprehensions, the same kind of list comprehensions that we have seen in Haskell. But in Scala, they are called for comprehensions. And maybe I should make this a little bit smaller. No, that doesn't look good, so I'm going to make it bigger. The layout here is a little bit messed up. But here you see, this would be the Haskell list comprehensions. It's called for comprehensions, and then it uses the same left arrow that we've seen in Haskell. So all the comprehensions work. In Scala, you can do pattern matching as well with a case statement. So, and you can define your own unapply method on an object, and then you can use that to do pattern matching. So it's kind of nicer or more powerful pattern matching even than in Haskell, because in Haskell you can only pattern match on the constructors of an algebraic data type, and in Scala you can tweak that. Scala is a rather big language. It has implicit parameters that kind of factor out the idea of Haskell type classes. In Haskell, when we have a type class, when you see the type constraint on the left of a type with a double arrow, the Haskell compiler will thread through an instance of that type class as an implicit parameter. And whenever you call that method or that function, it will kind of propagate that implicit parameter. But you cannot use this concept of implicit parameters separate from type classes. Now, there are Haskell extensions that allow for implicit parameters. And Scala took this a lot further, and there's many, many library functions that use implicit parameters in a very powerful way, and you can use that yourself. Okay, so enough looking at the cheat sheet. Let's finish by showing some Scala code. Where do we go? I want to go to my Scala window here. Make this a little bit larger for you. And I'm using the same, more or less the same example as I did before. So there's the main method. I print hello. I define a local function. I define twice. I print itself. And here I'm defining a local function that closes over some mutable state, and it mutates that variable inside here. So you see there's the mutable variable z, and I mute it inside here. Call this thing twice. So the second time, z will be 14, and then it will be mutated again. So let's run this code to see if everything works as advertised. Hello for, and you see here that when I call mutate twice, the first time it prints 14, and the second time it prints 15. So mutate is not a pure function. Let's add the explicit type definition. So what we see here is that mutate is a function that takes no arguments and returns an int, but it's not a mathematical pure function, because if I call it twice, it will give me a different result. But sometimes that is useful. All right, so I hope that you enjoyed this little overview of Scala. And if you're on the JVM, I would definitely consider Scala as a great language to apply the functional programming techniques that we learned in this course. See you next time.